Video is about integrating using the substitution method. Let's start by discussing why we might need a new method. So far, we can handle some integrals, but they were all fairly straightforward. We needed to undo the power rule or recognize some function derivative pair. But what if we were asked to find something like the integral of 3x plus 1 quantity to the fourth power? And reminder, what this means is we want to find a function whose derivative is 3x plus 1 to the fourth. So as we look at this, we might think it should probably involve something like 3x plus 1 to the fifth. Because we know when we take a derivative of some function to a power, taking the derivative decreases the power by 1. So if we wanted to end up with the fourth power here, we probably should have started with a fifth power. So let's just check. Maybe this is it. Maybe this is what we needed. So let's do a quick spot check. Let's take a derivative. And we'll use that chain rule. Remember, the chain rule would take the derivative of this function to a power, and we would get 5 times 3x plus 1 to the fourth power, and then times a 3, the derivative of that inside. So we're getting 15 times 3x plus 1 to the fourth. Well, that's not quite where I wanted to be, right? I wanted to take a derivative of something, some function, and get 3x plus 1 to the fourth, just that piece. And my guess, it probably came from a fifth power, is really close. I see that 3x plus 1 to the fourth showing up, but I have a 15 on the outside. So I realize, I've got to do something to compensate for that 15. So not quite 3x plus 1 to the fifth. So maybe if we need to compensate, I need to get rid of that 15. So maybe I should start with dividing by a 15. So maybe 1/15th 3x plus 1 to the fifth. So there's my guess. And I can check my guess by taking a derivative of my guess. So let's see what that would be. I'd have my 1/15th constant multiple, which can just hang out, and then times the derivative of that 3x plus 1 to the fifth power. So that's 5 times 3x plus 1 to the fourth times a 3 for the derivative of the inside. And what I'm going to notice is 5 times 3 is 15 and cancels with the 15. So I end up with just 3x plus 1 to the fourth, which was my goal. Remember, I was trying to find somebody who gave me a derivative of 3x plus 1 to the fourth. So it looks like my answer is 1/15th 3x plus 1 to the fifth plus c. Because remember, this indefinite integral, we need that constant of integration. Okay, so one thing that might come up with this this new kind of thing we're going to do is we might have to compensate for some constant that's there. And notice we were able to do that by with that 1/15th. Let's move on to another one. What if we were given something like the integral of 2x times the cosine of x squared? Well, as I look at this one, I think, okay, how could I have ended up with this as my derivative? And maybe my first thought is, I see a cosine x in there. I see that cosine of x squared, excuse me. I see a cosine, so I had to have started with a sine somewhere probably. If I'm going to get a derivative of cosine of x squared, I probably need a sine of x squared. So let's check. What if I take the derivative of sine of x squared? That would be cosine of x squared, and then the chain rule says multiply times the derivative of the inside, which is 2x. Oh, and that's exactly where I needed to be. So my guess was correct here, and I didn't have to edit at all. Sine of x squared is my antiderivative, or my indefinite integral. So there we go. So we can kind of see that undoing happening of, I needed the cosine of x squared, so I started with a sine. So let's keep going. The big idea in this section, as you noticed, kind of what we've been doing, is we want to figure out how to undo the chain rule. We're going to look at integrals where the chain rule has been used and undo the chain rule. So here we go. Let's do another example. The integral of 3x squared times the quantity 4 plus x cubed squared. And when I look at this, I know I'm looking at undoing a chain rule situation possibly, because I see this inside function here, and notice its derivative is showing up as well. So this inside function, 4 plus x cubed, its derivative, what is the derivative of 4 plus x cubed? It would be 3x squared. So I have something set up where I have an inside function and the derivative popping up. So that tells me that that's a good candidate for u substitution. And so let's talk about this method of u substitution. We sort of did it informally in those first couple examples. Now let's come up with a way to formally write it and think about how to make these work. So what I'm going to do is I'm going to let u equal that inside function, and I'm going to play around and come up with a way to rewrite this with some substitutions that give me an integral that's easier to deal with. So again, u is my inside function, so I'm going to make that my 4 plus x cubed. And then what I'll do is I'll find the derivative of u with respect to x. Now, I'm going to look at u and find its derivative. And what I want to happen is I want this derivative to also be in my function up there. So what is the derivative of u with respect to x? Well, it would be 3x squared. Okay, so let's look around. Do I have that? Yeah, I've got a 3x squared. So that's good. That means that this substitution is a good substitution because I have a u and my du showing up in the integral. Okay, and I'm going to do one little quick rewriting of this. I'm going to make this du equals 3x squared dx. You can kind of think about it as I'm multiplying both sides by the dx, and it sort of cancels out right here. But this method is going to help us because notice this 3x squared dx is right here in my integral, 3x squared dx, and then I can substitute real quickly. So let's do that substitution. We'll kind of add in here, that purple now is part of my du, and the yellow is my u. Okay, so let's write our substitution. Instead of this integral with respect to x, I now have the integral. Here, I'm going to start with my u first. Here is my u, and what is u? U is being squared, so I have u squared. And then I see over here a 3x squared and a dx that I need to substitute with. Kind of put those together. Those are my du. So I've transferred everything over in terms of u, and I'm left with this integral that hopefully should be pretty quick for us now because it's just integrating u squared with respect to u. So what will that end up being? Well, that's u cubed over 3. Or u cubed times 1/3, technically plus c, right? But we were asked a question about x's, so I don't want to give my answer in u's, so we're going to switch back over. So that would be 1/3, and what is u? U is 4 plus x cubed, cubed plus c. So we can see I transferred back over to being in terms of x's. So let's try another example. Notice this one is very similar to the one we just did. I've just, the constant 3 is gone. So let's talk about how to handle this one. Again, if I think I want to use u substitution, that's a situation where I'm undoing the chain rule. So if I look at my function I'm integrating, I want to see some function and its derivative popping up as well. So I look here, this 4 plus x cubed is sort of my inside situation again. And I know that the derivative of 4 plus x cubed, so if I choose u equals 4 plus x cubed, my du, oops, I wrote x squared. Let's fix that up, x cubed. My derivative du would be 3x squared dx. Well, I don't have 3x squared dx there. I have just x squared dx. So I need to figure out a way to fix that up to fit the substitution I've just decided may work out. So what I'll do, I'm going to rewrite this, x squared, just rewriting my integral here. And I see, here's my u, and I see part of du there. I see the x squared dx, but it'd be really helpful if it was 3x squared dx. So what I'll do is I'll just put my 3 there. But I can't just go multiplying things by 3. That changes my integral. So what I want to think about is how can I multiply by 1? Multiplying by 1 doesn't change it. So if I throw a 3 in, I should cancel that 3 out by putting a 1/3 in as well. Those together would multiply to 1, and I haven't changed the value of my integral, but I have made it where this du, this 3x squared dx, is showing up exactly where I needed it. So I have made all my substitutions, but I've kind of thrown in a tricky constant, that 3 and times the 1/3, to fix it up to be exactly what I needed it to be. So let's keep going. So this will be 1/3. Now I can substitute, now that I've found all the pieces there. I see my u is squared, so here's my u. And then my du is in this purple part right here. Okay, well that's not too bad. That's not too bad of an integral to handle now. I've substituted over to make it just a simple reversal of the power rule. So what will this be? 1/3 times, and now that u squared's antiderivative would be u cubed over 3, or times 1/3. So I end up with 1/9 u cubed. But I want to give my answer back in the variable I was asked about, so I'm going to make this 1/9 4 plus x cubed. Oops. Forgot my plus. 4 plus x cubed plus c. And there we are. Oh, I didn't highlight up here, but we can see the x squared and dx as part of the du as well. Okay, so let's do another one. All right, so when I look at this problem, again, if I think u substitution may be a viable method, my goal is to find some function in there, sort of the inside function, whose derivative is also showing up as well, with remembering that I can always use that method of multiplying inside and outside by a constant to kind of fix my constant where I need it to be. So let's look here. If I'm thinking about an inside function, my gut tells me to look at this 1 minus 4x squared. It's inside something, it's under that square root. And if I choose that, I have u equal to 1 minus 4x squared. And du, now du means take the derivative of the u you just chose. That's going to be negative 8x dx. And I look back to my function and that I'm taking the integral of, and I don't have a negative 8x dx, but I do have x dx, which means I'm only off by a constant, which means I can use my little constant trick to make this work out. So I'm going to rewrite my integral, x over square root of 1 minus 4x squared dx. And how do I need to fix it up? I really need a negative 8x dx to get du in there, which means I'll multiply by a negative 1/8 on the outside to fix that up. So let's check our substitutions. So my u is going to be that 1 minus 4x squared. Du should be negative 8x dx, and I see it right there. So I can substitute successfully for everything with my integral, which means u substitution should work now. So let's do those substitutions. Negative 1/8 times the integral. So what's going on? I have the square root of u on the bottom, and then that negative 8x dx is just du, but it might help to think of this as 1 du, because we kind of like that differential part, that du on the outside. It kind of looks a little bit nicer, and then I can see that 1 over square root of u. I'm not quite ready to integrate just like it is. That square root of u, I'd really rather see that written a different way, to use that reverse power rule idea. So I'm going to rewrite this. The square root of u is really u to the half. And since it's in the denominator, when I move it up, this is really u to the negative half du. Now that it looks like this, I can integrate a little more easily. So this will be negative 1/8. That constant just hangs out, waits till later. And then u to the negative half will integrate to u to the positive half, right? I got to add 1 to it. And now divide by a half. And if I divide by a half, that's the same thing as multiplying by 2. So there we are. I'm going to take a step and clean that fraction up. Negative 1/8 times 2 is a negative 1/4 u to the half. And now I can switch back to my x's. So negative 1/4 u is 1 minus 4x squared to the 1/2 plus c Or if I prefer, I could write this as negative 1/4 the square root of 1 minus 4x squared plus c. Either of those are good answers. All right, let's do another one. Okay, again, remember sort of what we're looking for. If we want to go with U substitution as our method, is we want to find something whose derivative is showing up or maybe off by a constant that I can fix. So when I want to pick my U, I want to choose something that is sort of an inside function who I see its derivative. So here, my inside function feels like this 3 plus x to the 4th, and just a quick spot check, its derivative would be 4x cubed. Oh, and I see an x cubed there, so I feel pretty good about that substitution. So let's do that. So that would be, u would be 3 plus x to the 4th. du is 4x cubed dx. And it's not quite there the way I want it to be, but it's almost there. So I think this is going to be a successful substitution. So let's rewrite 2x cubed over 3 plus x to the 4th to the 5th. My u is that 3 plus x to the 4th. I see that there on the denominator. And then my du is not quite where I want it to be. Notice I really need a 4x cubed, but I've got a 2x cubed. So how can I fix that? Well, if I need that 2 to be a 4, I could just multiply by 2, make that 2 a 4, and now a 1/2 on the outside. Alternately, some people like to take this 2 and just move him all the way out, and then multiply by a 4 inside and a 1/4 outside. That's also okay. You just need to somehow get that 2 to a 4. All right, so let's check our substitutions. We see the u there, and then I see 4x cubed dx, and that is my du. So I should be able to integrate just fine now. Let's make those substitutions. 1/2 times the integral. It's usually easier to kind of think of your u part first. So I have u to the 5th on the bottom, and then all of that purple is just du. So I'll just make that 1 du. And this is an antiderivative I can handle. So this is 1/2. I do want to rewrite it before I do it though. Maybe u to the negative 5th du. That way that reverse power rule is a little bit easier to deal with. So what is that going to be? 1/2. U to the 5th, or u to the negative 5, I need to add 1, so I'll get u to the negative 4, and then divide by negative 4th, so multiply by a negative 1/4. And then I'll end up with negative 1/8 u to the negative 4th. But I don't want to leave my answer in terms of u, so I will make that negative 1/8, and instead of u, I will put 3 plus x to the 4th, go back to my original u, to the negative 4th, and then plus c. Alternately, I could write this as negative 1 over, that 8 would be on the bottom, 3 plus x to the 4th power, if I moved that down, plus c. Both of these answers are good answers.